So yeah, we'll be picking up where we left off last week, which was on console-based applications. I'll give you guys a refresher on where we were, and then we'll see what we have to do next. So this is the simple application that we made, and it was just to illustrate one concept, okay? And that was the concept of arguments, So arguments are just strings that we pass into the application when we run it. So to remind you guys, if I run an application in the console like this, so, and I type a couple of names, so like Chris and Yusuf, then these two things, Chris and Yusuf, so console app one is the name of the program I'm running, right? That's the name of this executable file. You see console app one. So that's just the name of the program that I'm running, the compiled program. And then Chris and Yusuf are arguments that I am passing into this program. So if I hit enter to run that, you can see that it runs and it prints out the arguments. That's all this program does. So it says for each string arg in args. So this is saying for each argument in this array of strings called args, which is just Chris and Yusuf, it just prints out arguments, okay? So that's what we learned last week. It was just what this string args is. They're called arguments and they're passed into the program when you run it, okay? So yeah, that's one important concept to grasp. So that's how you can pass in at runtime after a program is compiled. You can pass in some information so that you don't have to pre-program everything. You can just pass some information in to the program as soon as you run it. So like quite a useful thing. That's where we left off last week, but there was one other concept that I had to teach you guys about console-based applications. Most of these concepts we learned, most of what you need to know about console-based applications, we learned during, like while working with Rex Tester. But there was one other concept about console-based apps that I had to teach you, and that was this concept of a file, okay? Wait, guys, spam the chat quickly, spam the chat so I have something to put in the text document. So I'm gonna call this chat.txt, okay? Help me, I'll add some stuff to chat. Okay, so here we've got a free insurance. Okay, so we've got a text file here. And basically all I'm going to do is I'm going to take everything that's posted in chat and copy it into the text file. Okay, there we go. So that's all in the text file now. So that's just our entire chat history inside this text file. Okay. Should we see about writing to the file first or new project? Okay, let's copy it again. Okay. Actually, no, so we'll see how to write to files later. So I'll show you how to read from a file now. And I remember at the end of chapter 6, we see this again. So maybe I'll save reading from it. Although it's very similar. It's very, very, very similar. Basically, so the other thing about console-based applications is that it's a good way to work with what is called a stream. Now, you guys know what a stream is in like normal language, right? Like if we Google stream define, you can see it's like a small narrow river, right? It's just water that flows in a singular direction. But we can see if we go down to the computing definition, it says transmit or receive data over the internet as a steady continuous flow. Okay, so actually this is a pretty bad definition of a stream because streams don't have to go over the internet. They can be just on the computer. So essentially how we work with files, and we'll see more about this in chapter 6 as well, but how we work with files is we open something called a stream, okay? So a stream can flow between any two places on a computer, basically. So for example, we could have a stream flowing from this text file to the console, okay? So that could be a stream. We could also have a stream running from the console to a text file, or we could have a stream running from a database to the console or from a file to the database. We can open up streams that flow in any of these directions, okay? And the reason it's called a stream is because the data is only flowing in one direction, just like a stream of water, okay? So to illustrate this idea to you first, I'm gonna open a stream. So we've got our text file here. And I'm gonna open a stream from this text file to the console, okay? And we'll see how the data goes from the text file to the console. That's what we'll do now. Okay, and then we're basically actually done with console-based apps because we'll come back to these stream ideas. So the one thing you need to do is you have to say at the top of your thing, using system.io. So system.io provides all sorts of streams for working with all sorts of classes for working with streams and those kinds of things, okay? So this is where we find all of these classes, okay? So what we do is in system.io, in order to read a text file, we'll use these, or either read or write to a text file, because remember, the stream can go from our program to the text file, or from the text file to the console, right? So it can go in either direction. The stream can go in either direction. So if we wanted to write to the text file, so from our program write to the text file, we would use what's called a stream writer, okay, stream writer. And if we want to go from the text file to the console, so we want to read the text file, we would use a stream reader, okay? So for now, I'm going to use a stream reader. I'm going to call it file, stream reader file, equals new stream reader. Don't know why I'm coughing so much today. So I need to tell it what file I'm reading, obviously. In order to open a stream reader from a file, I need to tell it what file I'm reading. Here I'm reading chat.txt. So I'm going to give the stream reader chat.txt. That's the name of the file we're reading. Okay, so that's gone and opened a stream. That's all that did. That opened a stream. And now we can read the file line by line, exactly like we can do with the console itself, okay? So with the console itself, in order to read from the console, I would say something like console.readLine, right? Console.readLine. And yeah, you can picture, so I could output whatever you type to the console, for example, like I'll just give you a quick example. So you guys know these commands, console.writeLine, console.readLine, right? So this is opening almost a stream from the console to the console, okay? Because we're saying console.readLine, and whatever we read, we print out, right? So I'm just giving you an example of how we would do this in the console, just reminding you of these commands. So if I ran this, unfortunately, it didn't wait for me to type, but let me, hold on. Let's say, yeah, so let's do it this way. I'm going to read in what you type to the console. So string x equals console.readLine, and then we'll print out x. So console.writeLine x. Okay, like so. There we go. Ah, still didn't wait. Okay, you can make it wait, but okay, let's just console.read. Yeah, we would have to tell it to wait. Like, okay, cool. Let me do it that way. String x. Okay, this became substantially more complicated than I wanted it to be as an example, but hopefully you guys bear with me here. Console.writeLine x. Okay. Oh, of course, I hadn't built it. Okay, I'm sorry, guys. I was being silly. I hadn't built the application. I'm silly sometimes. Okay, let me do this now. So you can see into string x, I can say console.readLine, and then we can print out X. So I'll say console.writeLine X. Okay, there we go. So this is saying like we're reading from the console. So you see it's waiting. So I can type something and then I hit enter and it prints it out. Okay, whatever I type to print out. So we read from the console to the console. Now, instead of console, we can literally just use file. Okay, like I can just type file.readline. Okay, and then I can say console.writeline X. So now instead of saying console.readline, which just reads whatever line you type in the console, this is going to read the line I type in the file because I opened the stream reader to the file. And then it's going to print out that line. So let's see what that does. Oh, we have to build it, obviously. Should just push F7. And you see it prints it out from Christopher to everyone at 9:03 a.m. And if we look into our text file, you can see that's the first line of the text file, right? And if we just run this code twice, so we read in from the file again, we read in from the file again, and we print out the output from the file again. Okay, so I just run the same code twice, basically. I'm gonna build that quickly. Let me just hit F7, there we go. And console lab 1, you can see now it says, from Christopher to everyone at 9:03 a.m. morning, sir. Okay, so those are the two first lines of the text file. Okay, so you can see that now instead of reading from the console and writing to the console, we're now just reading from the file and writing to writing to the console. So you can open the stream of information from the file. So if we just want to read the whole file, what we would do, how do we repeat code, guys? How would I repeat code? Anyone have any ideas? What structure would I use to go ahead and just repeat some code? Hey, Clark, you made it. Welcome. What structure would I use to just repeat code? Anyone have any ideas for what we can use to do this? So there's a piece of code that I want to repeat again and again and again and again. How do we do it, guys? There's lots of repetition structures available in C#. Does anyone have an idea for one that I can use? Okay, people are quiet this morning. I'll give you the answer. So it's a while loop, okay? A while loop. So we're gonna read the file while there are more lines to read in the file, okay? So in order to read a line in the file, we say file.readLine, right? That's what we do. We say file.readLine. That will read the next line in the file, the next line in the stream of information that we can read, okay? So if I say while, so there's a thing built into these files called the end of the stream. Okay, so you see streamreader.end of stream. And all this does is it gives you back a piece of information that tells you whether the stream is still open or whether it's closed. Okay. Can one of you tell me what is end of stream's type? If we look at that little blurb, what is the type of end of stream? What is its type? Bool. Yeah, exactly. It's a Boolean, right? So it holds true or false. So end of stream will be true when there are no more lines to read in the file, and it will be false while there are more lines to read. Okay. So this will tell me, are we at the end of the stream? Are we at the end of the stream? So what we're going to do is we're going to say, while we're not at the end of the stream. Do you guys remember what symbol in C# means not? Does anyone remember what symbol in C# means not? We can do some examples. Let's see. So I'm going to comment this out. Or I'll just print out here. So I'm going to say console.writeLine. I'm going to print out true. Okay, true. Okay, let me comment this and this and this. Okay, so I'm just commenting out this line so that it doesn't run forever. Okay, So if I print out true, console.writeLine true, that'll work. Okay, so you see it prints out true. Let's see what happens if I put exclamation points in front of that. Okay, so you see I got an exclamation point in front of the true. It now prints out false. Okay, so exclamation points inside C# means not. Okay, so this is like saying not true, which is false, right? Not true is false. So if I say file.end of stream, okay, so if we say while file.end of stream, this is like saying while we are, because remember, end of stream will return false if we are not at the end of the stream. Okay, so we need to use not end of stream. So while it's not the end of the stream, we're going to read the line. Okay, so I'm going to say console.writeLine, and we're going to read the next line from the file.readLine. Okay, so all that will do is print out our text file. Okay, so let's run it. You can see it prints out the whole text file, the whole chat file. Okay, see that? So it just said, while we're not at the end of the stream, read the next line and print it out to the console. So we opened a stream running from the file to the console. Okay, so hopefully that makes some sense to you guys. It's not a lot of code really, it's just understanding this new idea of a stream. We will spend a lot more time on streams at the end of chapter 6. It's basically what chapter 6 and the end of chapter 6 is about. So we will see this again. But for now, what you must understand is that a good way of opening and working with streams is in a console-based application. That's what you have to know now. So what we learned in this console-based application section is what an argument is. It's almost like a value passed in, or a string passed into the program at runtime, like when you run it. And we learned maybe a little bit about streams and how to work with files, but we will come back to that later. Okay, so that would bring us to the end of this first part of chapter 5. And yeah, so the second part of chapter 5 is not too bad, but I do need to remind you of something before we get into it. So I'm just going to jump back to Google Drive quick. So at the beginning of chapter 5 with this desktop applications lecture, I did show you guys this sort of thing. Let me show you the slide quick. I showed you this. Okay, and basically this was setting up this idea that there are two types of desktop applications. Okay, there are desktop applications that have a visual or graphical interface. Okay, so like a visual graphical interface. That would be like a Windows Forms application. That's how we would create these GUI interfaces, like applications with these GUI interfaces, or I mean, graphical user interfaces. And then there are console-based applications, which have this textual user interface that we've been working with since the start of this lecture, okay? So these are the two types of desktop applications that I showed you guys about at the beginning of chapter 5. And this, this is somewhat true. All of the applications that you interact with are one of these two, right? They either have a visual interface, a GUI, or they have a textual user interface, a TUI. So they're either a Windows form or they're a console-based application, okay? Or basically all of the apps you interact with. But these are not the only two kinds of apps that exist. Can someone give me like maybe an idea as to what the last type would be? So there is a third kind of desktop application. So it doesn't have a visual interface and it doesn't have a textual interface. What's left, guys? What's left? What's not included here? You might have to think a little bit outside of the box in order to answer this question. So not all applications have visual interfaces, and not all the applications that don't have visual interfaces have textual interfaces. So what do those applications have? They've got neither a visual interface or a textual interface. So how could you describe their interface? I suppose it is a difficult question if you haven't thought about this before. But yeah, I guess we can show you. So this third type, this very mystical currently type that I'm talking about of applications is called a service. And if it runs on Windows, it's called a Windows service. On Linux, they're sometimes called daemons. But yeah, so on Windows, they're called Windows services. We've heard the term services before when we were talking about web services, but these are slightly different. What we're talking about here is slightly different. So this is a Windows service. It's not a web service, okay? So yeah, let's see what this means. So not all applications have a visual interface or a textual interface. There are some applications that have no interface. Absolutely no interface. So what would you use such an application for, right? Like as of now, and probably what we've learned before, you would expect that any application, anything that we use and work with on a computer, it must have an interface. It's very pointless if it doesn't have some kind of input and output from a user, right? If it doesn't tell the user to do something or do something for the user. But it turns out that that's actually not the case. There are many, many tasks that just run in the background, that have no interface, that never have to communicate with the user, and that just work in the background. So to give you an example of one of them, for example, if you plug in a USB port to your computer, so if you have some device and you connect it to your computer, I can do it now. Let me just connect my phone. So if I take my phone and I connect it to one of the USB ports on my computer, you would hope that the computer would notify me of something, although my phone's USB ports are awful. There we go. It has notified me, I think. Or is this the... no, so that's for the LAN card. Okay, I think this cable is a bit broken. Let's try another. So I'm going to plug that in there. Hook this up to my phone. Okay, so my computer just went doop doop doop. I don't know if you guys heard it, but it gave me a little notification that I just plugged in something to my computer. So how does it do that? That program that gave me that little notification didn't have any interface. And you can see it now says Samsung Galaxy S7. You see it pops up with this notification. This program didn't have any interface. I didn't have to click a button saying, I want to connect something to my USB port. I didn't have to do anything like that, right? This program is running in the background. It's monitoring all of the ports on my computer. And when I connect something to a port on my computer, it automatically just notifies me. Okay, it automatically knows, it posts like a little event, it shouts out, it goes, hey, something's been connected to a USB port. Someone should probably do something about this. And that's its whole job. It just runs in the background, monitoring all of your USB ports. Other examples of this is if someone's trying to like copy something to your computer over like a network, or if you're trying to connect to a computer over the network, or the thing that monitors whether or not you have an internet connection. All of these are services. They run in the background. They have no user interface whatsoever, right? They have no user interface. So let's just discuss some of the differences now that we've got maybe a couple of examples of where these occur, but there's lots of these, guys, like all of your drivers, the thing that makes sure that your computer is able to work with your mouse and your keyboard and your speakers. The applications that monitor whether or not all of those things are up to date are services, okay? They just run in the background. You never see or work with them directly, okay? So let's discuss some of the differences between like a Windows service and one of these more traditional desktop applications that we've been working with. So like, let's use Windows Forms. You can imagine if we discussed with console-based applications as well, you'd be able to fill in the blanks. So a Windows service, the main difference, the primary difference, is that a Windows service has no user interface, none. And Windows Forms have a visual interface, okay? So, and console-based applications have a textual interface, okay? So those are the three types that we're dealing with. Here, we're just discussing Windows services and Windows Forms. So Windows service, no user interface. Windows Form has a visual interface. The next big difference is in the number of instances that run of these applications. So a Windows service usually, so you can imagine that I could have multiple users on my computer, right? Like currently I'm on the user called Joshua, but you can imagine like my gran or my mom or whoever could have a user account on this system as well, like their own user accounts. Now, if you're running a Windows Form application, say like Visual Studio over here, let's say we're running Visual Studio over here, this Windows Forms application is open on the Joshua user account, right? So if my mom opened Visual Studio on her user account, that would open another instance of the Windows Form application, right? Because I have one open over here, and on the other user accounts, I would need a second one open, right? There would be two different instances. Okay. Same with like Google Chrome. If I open Google Chrome on my instance, on my user, I mean, that would be one instance. And if another user on the computer opens opens Google Chrome, that would be a second instance. Okay. So, however, with Windows services, it's different, as you can imagine, right? Like we still only have one device. There's one computer. So the application that is monitoring all of the USB ports, for example, there's only one instance of that application. We don't need a separate one for each user. There's just one running on the entire computer. So a Windows Form, users will each have their own instance on their own user accounts. Whereas with Windows services, usually there is one instance of that Windows service on the entire device. Okay, so that's another difference. Another big difference is in the administrator's privileges or the administrator rights. Okay, so Windows services usually have more control over what they can do, because a user can't break anything with them, right? Because the user doesn't interact with them; they just run in the background. They do stuff in the background, and we'll discuss these privileges and how you handle security with Windows services a little bit later. But yeah, usually a Windows service has more control over the system. A Windows Form will usually only have the same privileges as the user that is running it, right? So like, for example, if the Joshua user has administrator privileges, then any Windows Form, any application I open will also have administrator privileges, okay? So you can see that usually the applications is just the same as the user at most, okay? Cool. The next big difference is what's called the launch mechanism. Okay, the launch mechanism. So a Windows service can be started automatically. Like when you switch on the computer, the service that's monitoring all of your USB ports automatically turns on. It just starts up and it just monitors your USB ports. You don't have to manually click something and like go to your desktop and double click some application that's called monitor USB ports in order for it to start monitoring. Or you don't have to go and click something and go, oh, by the way, I'm plugging in my headphones now. You must like listen for my headphones. That service just automatically starts up and it starts monitoring all of your stuff. It starts posting to the event log. And yeah, so it can be started automatically. Whereas Windows Forms need to be started manually by a user. Right? Like I need to go and open Google Chrome in order for this form to open, right? In order for this desktop application to open, I need to manually go and run console app 1 in order for this to run. It can't just randomly start up itself. Now you might be saying, whoa, sir, when I turn on my computer, it automatically starts up like Steam or Zoom, or like you know that you can set things to automatically start up when your computer switches on. Like my computer starts up a whole bunch of applications that do have interfaces, a whole bunch of Windows Forms automatically. And the answer to how that's happening is that Windows Form application is not starting itself. There is a service that is starting the application. Okay, so the service automatically starts when you turn on the computer, and you can tell that service, or Windows rather, can tell that service about any other applications that you want to also have automatically start. Okay, so basically a Windows form has to be manually started, but it can also be started by a service. Okay, so it has to be started by something. It can't start itself, whereas Windows services can just be set to boot automatically. Okay. Whereas Windows forms have to be started manually by the user, or they can be started by a service, okay, which the service was the thing that starts. Okay, anyway, so hopefully that distinction makes sense. So here's just some distinctions between a service and a form, and so hopefully you can sort of put together in your head like where these things are useful, okay? But we'll see a whole bunch of examples of services later after we create our own one, okay? And so with this distinction established, I'm just going to jump into actually going and creating a service. So services are just for basically monitoring things. Okay, that's what they're usually used for. They just monitor stuff. So what I'm going to do is I'm going to say new project. You can search here in like the whole long list of templates, or just type Windows Service. I already have it open here on the left because I've created Windows Service applications before. So on the left here, we can click Windows Service because that's the kind of application we want to create. Yeah, so we're going to select that. We want to create a Windows Service. Let's call this our MTA service, okay? MTA service. And the solution I'm going to call MTA 5.2 for like 5.2, okay, section 5.2. And let me just make sure to save it to the correct place so that I don't lose track of where everything is. Cool. Okay, so that's going to create a new sort of template for where I can create our Windows service. Okay, here it is. So let me just open this guy here. Okay, here's the good part. Ooh, okay. So you can see that it automatically specified it as service 1, which definitely isn't ideal for me. So I'm actually going to rename it because we did make its name. Did we not set it? We did set its name to MTA service. So that's interesting. I'm just going to jump into the properties quick and change the name of this to service 1. Okay, I mean let me just open up here, I think. Yeah, so I'm going to change this to MTA service. It's not allowing me to change the name. I mean, I suppose service 1 is fine because it is going to have to require to be changed in a lot of places, which is a bit annoying. So yeah. Okay, I guess we can work with service 1. So we can change the display name later anyway. But yeah, that is a bit annoying. Let's see. So if I open up properties, yeah. Yeah, it might not be worth changing this stuff. Because yeah, it'll require to be changed in a lot of places. So let's leave it with their default name. We can change the display name later, so you can get sort of your customization from that. So yeah, let's just jump in with this. So you can see that this is just a class. It inherits from this thing called the service base. So that's just a bunch of things that like a default service will always have. And our service here is called service 1, which is okay. Not the name that we set, but that's always the problem with using templates instead of programming yourself from scratch. Okay, but you can set the display name later when you install the service. So we'll do that later. Cool. So services run in the background and they just do things like according to a set of steps. So obviously it would be totally useless to have an application that doesn't do anything, right? Doesn't output anything, doesn't mention anything. Okay, so how services are implemented is that it's a sequence of events, okay? So the service starts, you can pause a service, you can stop a service, you can continue a service, you can shut down a service. Okay, so there's lots of things you can do with the service. That's these 5 things basically: start, stop, pause, continue, and shut down. Okay, so these are the sequence of events that a service can have. And when each of these events occurs, it can post something to what's called the log of events, like an event log. And you guys know what a log is. It's the standard, like a log book, right? It's just, actually, we can Google what is like log definition, log define. So obviously we don't mean a log of wood. We're saying more like not log mathematical definition. We want like log word. So obviously the main one, okay, an official record of events. Oh, wow. So it's even events. They even use the word events here. So yeah, we call this an event log. It's an official record of all of the events that have occurred with respect to that service. That's how services do things. That's how services keep track of what's happening, is it's just a sequence of events. So the main event is obviously the one that starts the application, and that's called on start. And you guys know something already about how these events occur, right? So we could find somewhere the thing that's linking all of these events together. Components, perhaps. It'll be here. Okay, I think so. Okay, so the you'll see when we add the next services. Okay, so by default, all the service can do is it can start and it can stop. Okay, it can start and it can stop. So the service can switch on and the service can switch off. Okay, that's all the service can do. And obviously, you can set a bunch of things to occur here. You could say like, okay, after you start, just start keeping track of what's happening. You can just say like, keep track of how much time has passed, and every 10 minutes post an event to the event log saying how much time has passed, for example. So like 10 minutes, 20 minutes, 30 minutes. So you can do anything you want in this method, in this on start method. And that's how you would actually program this service to start doing things, right? Like you could set up a sequence of events from the start method to actually do something. Okay, and on stop is the same, but there are a bunch of so there are these other options that we have, like we can pause and continue our service. And how we pause and continue our service is you have to set this variable that tells it whether or not it's allowed to pause and continue. Okay, so I can open that now. So let me just find out where the Okay. Where? This is a bit annoying. What's going on here? Okay, here it is. I don't know why it won't let me edit it in this nice way on the corner here. It's a bit annoying, but that's fine. So there's this Boolean called can, pause, and continue. And by default, it's set to false. So you can like set it to true. Okay, so you can set it to true. All right, like so. So now if you set can, pause, and continue to true, then obviously the service will be able to pause and continue. Okay. And likewise, if you set this dot can shutdown, so there's this thing called can shutdown. If you set that to true, now the application will be able to shut down as well. Okay. So now you'll be able to implement these events called pause, on continue, and on shutdown. So we can jump over and implement those. So we can say like protected override void on continue. Okay, like so. And we can do the same for on pause. And the only reason we can do this is because we set can pause and continue to true. So now we're able to pause the application and continue the application. We also set can shut down to true. So we'll be able to shut down the application as well. So we can say protected override void on shutdown. Okay, like so. So now the application is able to stop, continue, pause, and shut down. Okay. Cool, so that's a good start. We can do those things now. So what we want to be able to do is to post an event when each of these things occurs. And so I've mentioned this thing of like the event log. So the main thing you have to do is you have to basically connect to an event log. And there's a lot of sort of technicalities in how you connect to this event log. Okay, so the main thing is you use this object called event log. Okay, you use this object called event log. So we can create that now, and hopefully makes sense for you guys. So yeah, so we need to create an event log in order to actually be able to log all of these events. Obviously, that makes sense. So we're going to come over here. I'm going to open the toolbox. And if you remember that whole drag and drop thing that we discussed a while back, I'm not sure why it keeps closing the toolbox. If you remember that whole drag and drop thing we discussed a while back, this is no different. There is a thing called an event log over here. You see there it is. That's an event log. And so we can add an event log to our application. There we go. So our event log is called event log 1. Okay, event log 1. And we just need to tell this event log how to communicate with the event log that's built into Windows, basically. Or not basically, exactly. So we're going to do that now. So Windows has a thing called event log. Okay, event log. So here it is. You can see it there. So event log. This is just a property, so it gets an event log you can use to write notification of service command calls, such as start and stop, to the application event log. Okay, there we go. So we're going to check this event log. Now, what we need to do is we need to set up our service as a source. Okay, so we can say like .source exists, and we can say service 1. Service 1. So all this is asking is, does service 1, which is the name of our service here, does service 1 exist as a source? Okay. Does it exist as a source? If it doesn't exist as a source, so we can say if not event log.source exists service 1. So if event log.source exists service 1 is not a source, and like, for example, the other way to do this would be to say, if event log.source exists service 1 equals false. Okay, so this is the same as what I just said. If service 1 does not exist as a source, okay, so if our service is not a source on the event log, then we're going to create a source. We're going to set us up as a source. So we're going to say event log.create event source. The event source's name is service 1 because that's the name of our service. So that's the name of our event source. And the log that we are writing to is the application log. So there are a lot of different logs. There's like a network log. We'll see some of the different logs that exists, but we are writing our own application. So we're going to write to the application log. Okay. So there we go. That's just checking, are we set up as a source? If we're not set up as a source, then we'll create ourselves as a source. Okay. We then also need to tell our event log over here. So the event log of the actual service. So this first part is telling the computer that we exist. Okay. It's saying by the way, if you don't know about service one as a source, then please create us as a source, like set us up as a source. So this is telling the computer that we exist, this little bit of code here. Now we have to tell the application, like our little service here, we have to tell the application that that event log exists. Okay. So how we do that is we need to say, okay, application, which is event log one, okay, event log one is the name of our application's event log. Okay. We have to tell it, okay, you are a source. Okay, so you're the source called service one. So when you're communicating at the computer, when you're communicating with the computer, make sure you tell it that you're service one, because that's what it sees you as. It sees you as service one. Okay. And secondly, you are writing to the application log. So the log that you are writing to is the application log. So this is telling, okay, computer, if I don't exist as a source, if service one doesn't exist as a source, create service one as a source and allow it to write to the application log. Okay. So that will handle that problem. The computer will know about us and it'll expect us to be writing to the application log. Then we tell our computer, okay, by the way, I mean our application, then we tell our application, by the way, the name of the server, the source that you're expected from is service one. Okay? That's where the computer expects to see you. And it also expects you to write to the application log. So this is telling the computer. So let me just comment it. So this is telling computer about us. I mean, sorry, this is, telling service how to communicate with computer. Okay, and then this first bit is telling the computer about us. Okay, telling the computer about us. Okay, so those are what those code blocks are doing. Now we can actually start using our event log, and it's fairly straightforward to do. I think we can probably take a little break though now, because we have been going for sort of 55 minutes. So yeah, let's break for 10 minutes till 10:05, and then we'll come back and finish off our Windows service. And probably get started with the databases, chapter 6, the last chapter of the course today as well. Although I also have a Mentimeter quiz for you guys, so that might take us to the end of the lesson actually. Oh, that reminds me. Okay, I'm going to stop sharing my screen for a little bit quick, just so that I can open up the Mentimeter quiz without giving you guys the answers immediately. Okay. Cool. So the Mentimeter quiz is prepared for as soon as we finish chapter 5. Okay, I'm going to share my screen again. And yeah, so we'll get started again at at 10:05. Yeah, I'm going to go get some water quick. I'll be back now. If you have any questions, post them in the chat. Okay, let's jump back in and get the service working. So we've set up this event log now. The computer knows who we are and what to expect. We know how to communicate to the computer and what it expects from us. So we can now use this event log. And essentially, as you guys know, in any set of records, right, like if you think about back in the old pirate days, they used to write entries in a logbook, like on sailing ships, they write entries to logbooks. And it's the same here. So we have this event log, and we can write entries to the event log. So in each of these methods, our service is going to be very simple, very silly, but it's just going to write to the event log when each of these things occurs. When it starts, it's going to say, hey, I'm starting. When it stops, it's going to say, by the way, I'm stopping. When it continues, it says, I'm continuing. When it pauses, it's going to say it paused. And when it shuts down, it's going to say it shut down. Now, you guys might be wondering, what's the difference between shut down and stop? Why do both of these things exist? And the answer is that there is no set difference, okay? So you can make them different. The reason both of these exists is because you want to have the option, at least, to be able to have two different ways of shutting down. So to give you maybe a more relatable example, you can think that on your computer, you know that there's two ways to shut down, right? Like you could click power over here, and that goes through a specific shutdown mechanism, right? Like that might save all of your files, make sure that there's no updates running, make sure that you aren't breaking anything, and then it would switch off. The other way to shut down the computer is to just push the power button on the front, right? And that's like a more sudden shutdown, okay? So for example, you could say shutdown on shutdown would be the events that must occur in this slow shutdown. And on stop must be this more sudden shutdown. So it's just the reason they put both is so that you can choose to implement them in two different ways, okay? But by default, there's no difference. Okay, cool. So there's that. And now we can write entries to the event log. And how we do that is we say the name of the event log. Okay, so the name of the event log that we're using, which is event log 1, and we're going to say write entry, like so. Okay, write entry. And we give write entry just a couple of things. Okay, we tell it what message are we writing to the event log. So we can say that MTA Saturday service is starting. Okay. MTA Saturday service is starting. Woohoo. Okay, whatever. There we go. Something like that. We can also tell it, all right, what is this? What type of event is this? Okay, so there's a few different types of events that can occur. Okay, so I'll show you them now. So these are the event log entry type, and these are the types of events that can occur. Okay, the ones that matter to us, there's 3 ones that should matter to you guys. And the thing is, they're fairly self-explanatory. Okay, so there is error, okay, error, information, and warning. Those are the ones that matter to us. These failure audits and success audits are basically saying, if you're performing some kind of event and it's success, then you can return a success audit. If it failed, you can return a failure audit. But you don't need to know about these 2 things because we're not programming like an antivirus software now. But if you were, then these 2 would be important as well. But the 3 that matter to us are warning, information, and error. Okay, so these are the 3 types of events that can occur. Okay, so an error event, so you can read the little blurb that it says here. An error event occurs when this is a significant problem that the user should know about immediately. Okay, so usually this only comes up when you're about to lose some important functionality on the computer, like you're going to lose the ability to monitor your USB ports, or you're going to lose some important data, like you haven't saved something, for example. Okay, a warning is just like, this is a problem, like maybe something is out of date, right? So for example, maybe the driver that is running your mouse, maybe it's out of date. And so you're just warning that you should probably update this mouse driver. It's not like an immediate thing. You don't have to act immediately. It's not going to cause you to lose anything. but you should probably think about this. So that's a warning. And then there's information, which is just saying like, oh, by the way, this happened. Nothing bad or good is going to happen as a result of this. This is just saying like, just telling you that something has occurred. Okay. So guys, of these three, the event that we're posting here, this MTA Saturday service is starting, woohoo. What kind of events is this? Just to ensure that we're awake after our little break. What kind of events is this? Of those three, what type would I give this event, do you think? I'll wait for you guys to answer. Give you guys some time to think about it. So remember, we had these three events: error, warning, information. What kind of events is this? Not a particularly difficult question, I don't think. Trust your instincts and just answer. Yeah, exactly. It's an information event, right? So we're going to say, okay, this is information. Not immediately significant, nothing bad, nothing good. I mean, it's a successful operation, so that's good. But yeah, it's not like you don't have to take immediate notes of this. And then the last thing you give it, so you see it tells us what we need to give it. We give it the message. So our message is that MTA Saturday service is starting. We give it the type, okay, so information. And then we give it the event ID. So this is a way, so you know what's silly? They call it an event ID, which makes it sound like it should be the ID of the event, right? Of this event specifically, but actually it's more of an application ID, okay? So we're gonna make our application ID 1001, and every single event, because you can see it even says there at the bottom, event ID, the application specific identifier for the event. Okay, so the event ID is for the application. It's the ID of the service. It's not the ID of the event. So why they called it event ID, I don't know. They should have called it service ID, I think. But regardless, that's the name they went with. But yeah, so just know that the event ID is not going to be event specific. It's application specific or service specific. Okay, cool. So this is a 1001. That's going to be the ID of all of the things that we post. Okay, cool. So that's how we write an entry to the event log. So that's going to tell when the application starts. This is the little message that we're gonna post to the event log. Okay, and so let's just do the same basically for all of these other events. I'm going to use that special trick that I showed you guys a while ago, where I say Control Alt, and I click at each line, allowing me to edit multiple lines at once. Okay, like that, because all of these are going to look very similar. Okay, so we're going to have events log 1. Okay, event log 1, that's the name of the event log that we're writing to, dot write entry. So dot write entry. It's not going to allow me to use autocomplete. Okay, there we go, dot write entry. And then we're going to have a message. Okay, all of these are going to be information. So I'm going to say event log entry type. Okay, event log entry type is information. And the ID of all of these, because remember, it's the service specific ID. The ID of all of these will be 1001. And what we're going to do, so in the message, I'm going to start the beginning of the message by saying MTA Saturday service is, and then we're going to have some message exclamation point. Okay, cool. So that's going to be the start of our message. Inside the stop events, I'm going to say the MTA Saturday service is stopping. Okay, makes sense. Inside the continue events, I'm going to say the MTA Saturday service is continuing. And continuing just means like unpausing. Okay, or continue means to unpause. Okay, continue just means to unpause. The MTA Saturday service is pausing, and the MTA Saturday service is shutting down. Okay, left out the U, shutting down. Okay, there we go. So that's all our messages. So those are all of the events that we're posting, and that's our service. Okay, it's very simple. You can imagine if you ran like a while loop here, inside the while loop, you could perform some system monitoring, right? Like that's how you would usually do this. You could perform some sistering monitoring inside the while loop, and just do certain things when certain things occur. Because you can also monitor the event log, right? Like you can also monitor the other things that are occurring on the event log. And when other services give specific events, you can do certain things, etc. And you can create this whole interconnected thing. But we don't have to cover services in that much detail for this course. It's more important that you just get like a general sort of gist of how it is they do things. And the big thing is that everything's done with events, okay? Like it's just a chain of events that occur, and each service that's running in the background, and many applications as well, will just post to this event log, and everyone just looks for the events that they care about. Like maybe some are looking for errors that are occurring, some will be looking for warnings, some will be looking for things that are for updates, etc. So everything will just look for the events that it's looking for, and do certain things when those events occur. That's the main thing you must know about services. And then also just like this event log source, okay? That specifies the name of the service posting. Yeah. And now we get into probably, I think, the more interesting side of Windows services is in understanding how and why Windows has installers. Okay, why are things installed, basically? So in order to run a Windows service, it's a bit complicated to run, actually. Like you can imagine, a console-based application is very easy to run, right? You don't have to install it. It just compiles and you run it. Like as you guys have seen, right? I can just run console app 1, it just works. There's no installation process, there's nothing like that, okay? Windows services are different. They're more difficult to get working. It's more difficult to get them up and running. You have to install them, okay? And in order to install them, we use something called a Windows installer, And this specifies a bunch of different information about the service. And it does this in 2 separate classes, okay, 2 separate classes. So I'm going to show you, I'll jump between the sort of theory discussion and what we're doing while we're installing our service. So I'm going to jump back to this service designer where we added our event log. And I'm going to right click and hit add installer. Okay. So I clicked add installer, and you can see this is what it added. So we've now got an installer. It's called project installer. You see that? And it added these 2 things: service process installer 1, and service installer 1, So there's these 2 separate items here. We've got a service installer, and we've got a service process installer. Okay. So what makes these different? Why? Oh, sorry about that. Why do both of them exist? Lost my voice there. I'm going to have a sip of water quick. Why do both of them exist? So the reason both of them exist is that usually when you create a service, you can imagine in like a larger project, you would have multiple services as a part of the project, okay? You would have more than one service as a part of your project. So there are, so basically there is information that is specific to the service, and there is information that is specific to the entire project or the entire application. Okay, so let me just, once you see the type of information that is specified in each, you'll get it. So inside the service installer, you can see all it mentions is the service, right? So inside the service installer class, you see it just mentions service. It's just service installer, okay? There's nothing else. This is service specific information. So our service is called service 1, and this service installer specifies that service specific information, okay? So the 3 important parts of service specific information inside the service installer are the display name of the service, a short description of the service, and a start type, okay? A start type. Those are the 3 very relevant pieces of information. So let's just go through each one of them. So display name, that's probably pretty self-explanatory, but let me just mention it. So if you guys remember, our service is called service 1 over there. Our service is called service 1. Okay, service 1. Now, we might not want to, there may be other services on the computer also called service one, right? There may be many, many other things on the server called service one. We might not want to call our service one after we install it. And so we are allowed to give it a display name, which is the name that the computer will use to refer to our service after it's installed. Okay, so that's what a display name is, fairly self-explanatory. Description is also fairly self-explanatory. This is just a description of the service so that when you check all of the services on the computer that are installed, you're able to know which services are important to keep, what each service is doing. So you just give a short description of it so that the user doesn't just uninstall it without knowing what it does, okay? And last, we've got the start type, So this is like, there's three important start types that we must know. You can either start a service manually, you can start it automatically. So if you start it manually, that means you have to go to the place that we'll see it now, where we manage all of the services, and you would have to manually click like, okay, start this service, okay? If you start it automatically, that means when you switch on the computer, when you log in, or when you switch on the computer and like arrive at the Windows login screen, the service will just automatically be booted up already. Okay, so if you set it to automatic, it's automatically going to start the service for you when you turn on the computer, when you switch on the device. If you set it to disabled, then it can't be started at all. It can't be started manually and it can't be started automatically. It's just disabled. Okay. So like that's not in use. Okay. So fairly self-explanatory, these three options, and they're in the service installer class. And you can see they're all specific to the service itself. So you can imagine if we were using this one installer to install two different services, each of the services would have its own display name, its own description, and its own start type. Okay. Okay. Cheers, Clark. Good having you. See you next weekend, and I'll upload the video so that you can check out the rest.
Thank you. Thank you. Thank you.
Cool. So you can see that they're all service specific, right? Each of the services would have their own display name, their own description, and their own start type. The service process installer would be the same for both of the services, okay? Because this information is now specific to the application itself. And the main thing, basically the only thing that we use the service process installer class to specify is this account property. But let's finish setting up our service installer. So I'm going to jump to properties, and we're going to set the display name of our application and some other information. So I'm going to open up the service installer in properties. Okay, so here it is. We've got a description. So this is just example service for MTA Saturday. Okay, so it's just an example service that we're setting up. The display name of our service, we can make this whatever we want. This is just the name that the service will have inside the list of installed services. Actually, we can just call it Clark because, yeah, just to say goodbye because he just left. And so it also starts with a C, so that's good because it'll appear at the top of the list. Okay, so I want to put it at the top of the list so we don't have to scroll through this whole long list of services to find our one. So I just call it Clark. And we're going to leave the start type on manual because we're not rebooting the computer now anyway. So we're going to go into the list of services and manually start it up. But you can see I could set it to automatic or disabled as well. Boot and system is for like drivers and stuff that need to be started before you even get into Windows. But we don't want to... We're not fiddling with that stuff. That's for drivers and whatever. So we're going to stick to just the three you need to know are manual, automatic, and disabled. Okay. Cool. So that's all of the service-specific information specified. We've got a display name. We've got and we've got all that information there now. I'm not sure what's going on with my taskbar there. Wow, Zoom's doing some weird stuff lately. Cool. So the next thing is this account property, and this I think is quite important, quite nice to learn. So Windows computers have a certain way of handling permissions, and by the way, this is the reason why Windows computers get so many viruses and like dangerous viruses, okay? It's because it's handled in this way. So services can be installed on 4 different accounts, okay? They can be installed on the user account. So I can show you these options over here. So if I jump into the service process installer, just open the properties for that, you can see that there's this account property over here, accounts. So it can be set to user, local system, network service, or local service. Okay, we're going to set ours to local service, and we'll discuss why now. Okay, so let's check this out. So we've got these 4 different options. Okay, so we've got user. What this means is that the service will be installed on the user's account. Okay, we're not going to use this. The reason we're not going to use this is because you then have to specify the username and the password of the user who's installing the service, which is just annoying. Okay, I don't want to have to type in my username and password every single time I'm installing the service. So we're not going to use the user account. But then it's installed with the user's permissions. Generally speaking, it's quite a safe way to install a service, okay? Because you have to specify the username and password. There's also a local service. So this is the best way to install services. It's the safest way to install services. And what this is, it's exactly like one of the user accounts that you set up on your computer. So like you set up a user account for yourself, your brother, your family, whatever. We're on my user accounts. It's basically the same as that, except Windows sets this up for you, okay? The local service user is a user account that exists by default on all Windows computers, okay? It's a default account that always exists, and it's just designed for you to install services safely, okay? That's where you install services usually. And it's called non-privileged. Why is it called non-privileged? Because it doesn't have administrator access. Okay, it can't like just randomly disconnect you from the internet. It can't just randomly start deleting your files. It can do like basic tasks. It can monitor things. It can read certain things. And its privileges are very controlled, very limited, and it can do sort of normal stuff. You can also install on the network service user account. And this again is just a default account that exists on all Windows computers. And this is created specifically for network services. So it's very similar to a local service, except this network service is also able to access your network. So if you have like a LAN set up where you can communicate with other people's computers, or you can communicate with the printer or anything like that, or some Wi-Fi, for example, a network service is able to also work with those things that your computer is connected to. So it's no longer just limited to your computer. It has access to the network as well, but it's also very limited in its privileges. It can't just randomly disconnect the network. It can't go and break stuff. It just monitors stuff. It can notify stuff, do some basic things, okay? And then there's local system, and you can see this is highlighted in red because this is dangerous. Like if a virus gets access to the local system account, if a virus installs itself in the local system accounts, it will be able to do whatever it wants with your computer. It will have system-wide control. It'll have full network access. It'll have administrator privileges. And basically, it would be able to destroy everything, okay, break everything. So local system is very dangerous. The fact that it's even an option is like like a default option is quite interesting. But it's also, yeah, it's a default account. It exists on all Windows systems. Obviously, it has to exist because you need to be able to install stuff there. Like some people will need access to some people will be creating services that need access to those administrative privileges, like Windows themselves. Okay, but yeah, it is quite dangerous. It's quite a dangerous option. Okay. The standard way is to install on local service because it's a default non-privileged user that has local system access. Okay. So yeah, that's that. So those are our options. We're going to install ours as a local service because we're being safe. We don't want to break anything. And there we go. Okay, so that's that. That's Windows installers. And so now we've basically gone and created a Windows service. So I'm going to build this. Going to compile that quickly. And now we're going to jump over and just install our Windows service and see if this thing works. Okay, so I'm going to jump back to my workspace just so that I can find it. So it's MTA 5.2, MTA service, debug. Okay, there's our service, MTA service.exe. Okay, so what we want to do is install this. Obviously, we want to install it. So I'm going to open up this. I'm going to go into CMD. I'm going to open up this directory in CMD. So I'm going to type, I'm just going to type CLS just to clean up. So CLS will just give me a new fresh terminal. And then I'm going to type, okay, I want to change directory to that directory that's holding my service. Okay, so we're now in this directory that's holding the service. You can see we're in, wait, are we in the correct place? Why did it not? Okay, no, we are not in the correct place. Sorry about that. Oh no, we are. We are. Okay, sorry, I don't know why I thought we weren't. We are in the correct directory. You can see we're in MTA 5.2, MTA service, bin debug. Okay, we're in the correct place. Cool. So what we're going to do is we're going to install our Windows service. Windows has created a lovely console-based application called install util. Oh, wait, but I need to run my command prompts with administrator privileges. So I'm just going to do that quickly. Sorry about that. In order to install the service, we're going to need a command prompt that has administrator privileges. So I'm going to scroll down to this command prompt, and I'm going to run it as administrator. Okay. So I'm just running as administrator. There we go. Cool. So we're now in one that has administrator privileges. So that's good. And I'm going to chadr to that directory again. Okay, there we go. So now we'll be able to install the application. Okay. So how we run it, they've created this thing called the install util. Okay, util stands for utility. It's just something that's useful. Okay, like a useful extra. We're going to use install util to install our service. Okay. So what I'm going to do is and we give it the service's name as the arguments. So I'm going to say install util, and then the name of our service, okay, which is MTA service.exe. And we're going to hit enter. Okay, it failed to install for some reason. Let's just see why it failed to install. Creating an event log in log application, an exception occurred. The specified service already exists. Really? Wow, okay. We should probably give our service a different name then. Why is it saying it already exists? The file located at MTA service.installing, installing assembly, log2 console, installing service 1. Oh, it was installing service 1, and it said a service called service 1 already exists. A source called service 1 already exists. Okay, that's interesting. So let's change maybe the name of our service, I guess. I did think we should have probably done this earlier. So I guess we're just going to do it now. So I'm going to change the name of our service to MTA service here. Okay, MTA service, like that. Okay, quite crazy. So there we go, MTA service. Okay, I'm going to rename the file to be MTA service as well. There's a lot to change here. Renaming something is not as trivial as you might think. But hopefully that'll automatically update everything that's going on here. Okay, cool. So it did change the initialization to MTA service. Let me just jump over to initialize component, make sure that changed to MTA service. It did. And this guy also changed to MTA service. And we're going to need to change the name of our event source as well to MTA service. Sorry about this, guys. Okay. These live demonstrations always go so smoothly. I think it must have been with one of the other schools that I created something called MTA service. So yeah, sorry about that. Okay, let me see. Hopefully this just compiles nicely. It does. Okay, and we're going to try installing it again. Still failed. Okay, installing service 1. Why did it think it's installing service 1 still? Let's find out where it's specifying this name service 1. We're going to have to do some hunting here. Okay, so service 1, event log, that's fine. Okay, MTA service, we must just open all of these properties, I guess. The file name's correct. The name is correct over there. Name is correct over there. project installer might still be calling it, referring to it as MTA service 1. Service installer 1. The service name must be MTA service. There we go. Okay, and this one's name. Okay, okay, I think we should be good now, hopefully. Yo. Okay, cool. So let's see what happened here now. So it says the commit phase completed successfully. The transacted install has completed. Okay, so sorry about that. That was awkward, changing all the names of our stuff. But now it did manage to install finally. So that's great. Okay, that's great. So it installed, and so now that should just work. So we're gonna go ahead and start working with our service. So we need to go to like the service manager, it's called. I think it can be a mission to find. Probably the easiest way to do it is just go this PC and hit like manage. It's probably the easiest way to find it. So this is going to give us a list of all of the services that are installed on the computer, and hopefully we're going to find our service on that list. We're going to be able to start it and it'll work. Okay. Sorry that the live demo didn't go as smoothly as I wanted, but there we go. So I'm opening up services, and this is going to give us a list of all of the services running on this computer when it eventually opens. It always takes a little while the first time it opens. Okay, here are all of the services that exist on our computer. Okay, as you can see, there are quite a lot of them. So there's network service. I'm just going to scroll through the list. Maybe we can find some interesting ones that you guys might, so that the example might help you guys out a little bit. So you can see that's, okay, so Xbox has a lot of services running, Windows Search, Windows Security, so that's doing like security monitoring, something that's handling encryption, the firewalls that are running on your computer, all of the firewalls, keeping you safe from viruses and whatever, threat protection service, and you can see its description is Windows Defender Advanced Threat Protection Service helps protect against advanced threats by monitoring and reporting security events that happen on the computer. Okay, Windows Backup, so there's a service that's handling all of your backups and stuff. An update service, making sure that your, keeps Popcorn Time updated. Okay, so there's this application called Popcorn Time. That's like an illegal streaming service, basically, like almost a Netflix, but free, I guess you could call it. And so they have a service that makes sure that their system's always updated, their application's always updated. So yeah, there's lots. Plug and play, okay, cool. So that's cool. So yeah, lots and lots of services installed on the computer. You can see our service is right here, conveniently called Clark. Okay, there it is, Clark. And you can see there's our description. Example service for MTA Saturday. Okay, you can see its start type is manual. It's installed as a local service. Okay, now let's see, if I click start the service, hopefully it manages to start successfully. It did, so that's fantastic. You can see its status is now running. Okay, its status is now running. And now we can jump to the event log where we can see all of the services that are, all of the events that have been posted. So you can see it's in the event viewer here, the Windows event viewer. Okay, the Windows event viewer. We must open, I think it'll be under the application, the Windows logs. Okay, the Windows logs. We are writing to the application log. So you see there's other logs as well. There's the system log, the setup log, the security log, and the application log. We wrote to the application log. So I'm going to open up the application log. That's just opening there. It does take a while, I remember always, because there's lots of events being written at all times. Okay, guys, so there's definitely a lot happening in these logs. Okay, here we go. So we've got open the event log over here. So you can see it says here we've got a log from MTA service. You can see the ID is 1001. That's the ID that we specified. And you can see it's an information type, and you can see it says MTA service, MTA Saturday service is starting, woohoo. And so cool. So that's managed to start our, our service. And you can see that there's lots of warnings. Like if I scroll back through all of the previous services, all of the previous events that have been occurring on my computer. You can see there's lots of warnings, there's lots of information. There might even be an error or something somewhere. There's an error. Let's see what happened. What broke? The cryptographic services service failed to initialize a catalog database. Oh, this is probably when I was installing something for chapter 6 for one of my previous classes. So it failed to install a database that we used as an example. Okay, so cool. But there's our event that we just made. And you can see if I jump back to services and I stop the Clark event, so let's say I click, or let's say I pause. So I'm going to pause the Clark event. So I pause the Clark event, can jump back to the application, and you can see it says MTA Saturday service is pausing. Okay, cool. So it paused. I can jump back to services, go to the Clark event. I can resume it. So that's continue. I can continue the service, and you can see it loads, jump back to the application log, and you can see it says the MTA Saturday service is continuing. Okay. And you can see if I jump back to the Clark events, I can click stop, jump back to the application, and you can see it says MTA Saturday service is stopping. Okay, so you can see we can get all of our event logs to print out some of their information. Okay, and you can get like details about the event, like when it was printed and all of that kind of stuff. This is called the event viewer. Okay, you can see what computer it ran on, what the log name was, what the source was, what the event ID was, what the level was, all of that kind of stuff. Okay, cool. So that is that. I did think we would have, we would be doing this. So, okay, that's the other thing. I suppose I should show you that as well. So we've now used this service. You can probably agree. Having this service running in the background all the time probably wouldn't be that great, right? Like I don't want this installed on my computer permanently. It's not a particularly useful service. It's not doing anything for me. So you can uninstall these services. Okay, so that's the next thing I want to show you. You can uninstall the services by saying, okay, install util. So you run the same command, install util mta service.exe, but you add one extra thing. Okay, you add one extra thing. You just add -u, and the U stands for uninstall. Okay, so install util -u, so uninstall mta service.exe, and that's going to go ahead and uninstall the service. And you see it says at the bottom here, service MTA service was successfully removed from the system. The uninstall has completed. So now actually, if I jump back to the Windows Event Viewer, let me just jump back to it. So I'm going to open up manage. Okay, manage. If I open up the services over here and scroll down to C, well, I guess we won't see anything. That's the whole point. You can see that Clark is gone. The service was uninstalled. Okay, the service was uninstalled. Okay, so that's that, guys. That's actually it for services. So you install them with install-util.exe, and you can also uninstall them with install-util. Okay, cool. So we were going to jump into this Mentimeter quiz. Since there's so few of us, I think maybe let's save it for next time. And so I'm thinking, okay, what I'll do, I don't want to completely waste the time. We will end a little bit earlier today, though, because we are now finished with chapter 5. That's the end of chapter 5. I do want to tell you guys, so I'll post information about it on the WhatsApp group as well, though. Please do attempt to complete the chapter 5 knowledge assessment, starting on page 138 of the PDF. Okay, it was posted on the group a while back. I understand, though, you guys are probably, a lot of you are starting with exams and stuff, winding up the year at work as well. So that could be, I understand if it's a bit of a mission. But yeah, so next week we're going to start with chapter 6. It's a very, very interesting chapter, rounds out the course nicely. We're covering relational databases. Quite a lot to get through, definitely quite like a detailed and large section. So I don't want to start it immediately. Along with this section each week, I'm going to give you like a little bit of a database module where you'll be able to go online and learn some extra stuff, like some short quizzes, some tutorial videos, etc. They shouldn't take too long to work through, maybe like 30 minutes to an hour to work through each one. And that should help like sort of supplement the knowledge you gain from the lectures, okay? But for now, for this week, I think we can leave it there. We did finish with chapter 5, which was my goal for today. It would have been nice to do the Mentimeter quiz, but I'll save it for the start of next week's lecture, okay? So yeah, let's call it there. Thank you very much for coming, guys. You, Chris and Yusuf, you're very dedicated. It's cool to see. Well done. And yeah, I'll see you guys next week. Yeah, cheers, Yusuf. Thank you for coming. Cheers, Chris. Thanks for coming. I'll see you next weekend. Yeah, you too. Enjoy your weekend as well. Bye-bye.